A while ago I got this vacuum pump. It didn't work quite good, so I took it apart and found out that this inlet valve had broken. So I glued it back in place. I want to share this video because this vacuum pump had a very special piston setup, and the pistons were pretty special. This is the only vacuum pump I have found out that had double acting pistons inside it. This one has two double acting pistons, and when it's double acting means when the piston goes down it sucks air from the top and pulls out the air from the bottom, and when it goes up it sucks from the bottom and pulls the air out from the top. Most pistons and vacuum pumps doesn't work like that. They have a single acting piston instead. That means that the bottom part is open and only the top part is connected to the pressure out and the vacuum in. But this one has double acting, so this is a pretty unusual vacuum pump. And on the front here we got this vacuum regulator, a pressure gauge, and this on-off switch, and some logic circuit inside it. This is a spring-loaded switch, so it goes back and forward. And on the bottom here we got a connector for a foot pedal. On the side here we can see this inlet connector, and on the outside here is supposed to be a filter and a separation tank, but they are not here. Let's see how much vacuum we can get. Yes, that's pretty good. Yes, my finger is not so good sealed. So yes, let's open it up and see how it looks inside. So yes, I turned it around and let's take the lid off. This is how it looks inside. With the two double acting cylinders. We got this seal here. Let's come a bit closer. So yes, I got a better close-up. This is completely sealed on the bottom here. On the top here we got the rod coming in for the piston, and here's the seal, and here's the valve pack. If you open up the valve pack, a bit careful, I don't want to destroy anything. You can see here, these are plastic valves themselves. Here's the receiver. This is the vacuum receiver, I think. Yes, this is the vacuum receiver here. And we got another one on the back here, which is a pressure receiver, and that goes to this tank here. For redundancy, it got two pipes on the outlet if one gets clogged. So I'll put the valve pack back together now. So this valve pack is back together. I was wrong with that. This is the pressure outlet, and that's the vacuum hose here. This one goes all around and goes into this tank here. And here you can see there's a pipe on the top here and a pipe on the bottom that goes to this valve pack. All four terminals goes to this middle plate here. And we got these plastic valves, one for a vacuum block and one for a pressure block. And there's the motor, and we got a little drive train on the top with some gears. Time for the interesting part. Let's turn it on. Yes, you can see that these cylinders goes back and forward. That's to minimize the stress on this sealing on the top. the total gear reduction is 1 to 18. So this shaft needs to rotate 18 times and this just rotates 1 time. And here this rotates almost like 5 times and this rotates 1 time. So the gear ratio here is like 13 to 1. Here we got the logic circuit. So there's the logic circuit. Let's turn it off. It's a bit loud. So you see we got the transformer. We got a jumper over here to change functionality. We got a triac, optocoupler, we got a full bridge rectifier, and smoothing capacitor, and this logic gate here, which is a double flip-flop. This little jumper here, this is a little special functionality with this one. So let's turn it on again. And now we got a power cut and this stops running. I pull the plug out. Let's pull the plug back in again. And it doesn't turn on. But if we change this, take away that jumper and put it on the other position. Now the power comes back. It starts running. Turned off by the switch. And unplug it and plug it back in. So yes, this switch will just change if it turns on when the power comes back or if it remains to turn off when the power comes back. But I just want it to be on that position. Yes, now it's correct. I don't want it to begin running after I got a power blackout or when I pull the plug out. And another thing I wonder about is why they have chosen these angles on these two. Now this is on the lowest position, and this is not 90 degrees, it's like 100 degrees off with this one. So why they haven't done 90 degrees, I don't really know. So that's another thing I've wondered about this. Or if one screw had got a bit loosened and it lags a bit. So no, I don't know why they have done that. 100 degrees off instead of 90 degrees. So I hope you found this video interesting. Thanks for watching.